So one of the things I've been doing, I started in that STL Superfund Technology Liaison position in 2015, 2 weeks before Gold King happened. So I got that going for me. So one of the things I've been trying to do over the last several years is draw attention to the issues that we have with mining, and it can be a challenge when you think about some of the other things that the agency has to tackle and do research on. I was just down in Colorado Springs at the PFAS summit looking at the per and polyfluoroalkyl substances that are now showing up in a lot of our drinking water. So sometimes it can be tough to chase down research dollars for projects that might help improve water quality and save some fish when we have folks that are potentially getting bladder cancer from drinking per and polyfluoroalkyl substances. So it's been a challenge, but we've made a lot of progress. Folks have, Betsy mentioned the various Superfund task force and administrator priority lists. I would encourage you to check those out, but basically most of those Region 8 sites that end up on those lists are mine or mineral processing sites, basically smelters and mines. So a lot of agency focus on it here in the region. Each year, the Office of Research and Development, about every 4 or 5 years, the Office of Research and Development does something called Strategic Research Action Planning. Myself and a number of colleagues actually produced a white paper to try to help ORD look forward 5 years about what they should be conducting research on over the next few years. We kind of broke it down into three site types that comprise, I would say, the majority of our Superfund sites. These were large sediment sites, large groundwater plumes, and non-aqueous phase liquids. And then the last one, which we were able to get on the list, is mine and mineral processing. So ORD is well aware of our needs in terms of some of the challenges that we face at these mine sites with water, with some of the solid matrices, and also at our smelters. Of course, this sort of event is helpful if folks were lucky enough to go to the Design and Construction Conference, which happens in Denver every year. I was impressed to see that in 2017, the entire, it's about a 2-day conference, an entire day was dedicated to mine-related topics. So we're making a lot of progress. The other thing I do in Region 8 is we do a lot of, we have speakers come in, Linda Figueroa, professors from School of Mines, and folks like that coming in talking about their research. I run a mining series where we have folks do that. And we're going to try to do something a little bit larger in 2019 with the Office of Research and Development. It may end up being virtual because it's very difficult for us to get travel dollars to get folks to places these days. But stay tuned. That will be accessible for all of you folks. Dan Powell talked about that Clue-In platform. That's where we will be sharing a lot of these presentations in 2019. And we hope to actually have a sort of a round the regions, Western regions, so regions 6 through 10, we'll be talking about mine-related topics over a series of weeks. We also have our Regional Science Council, and in particular, we've been trying to get the region to come up with science priorities. I can't share those with you today because we haven't had them officially blessed by the regional administrator, but they are the typical things you would see, the PFAS compounds I mentioned, nitrosamines in water, some of our harmful algal blooms, and I actually got mines and mineral processing sites onto that list, and I'm hoping that will be made available soon, but it's definitely on our radar screen as well. We work closely with our state and tribal partners, folks like ECOS, ITRC, ASWAMO, et cetera. So the first one is actually something that was not completed here in the Bonita Peaks Mining District, but it has some parallels. So we did a project at the Colorado smelter site from about the time I started in 2015 through 2017, and even prior to that, when I was in headquarters working with the Office of Superfund Remediation and Technology Innovation. We started to help out with some design of incremental soil sampling. We take small increments and pool those into larger volumes, and we process those samples. And we do a lot with the X-ray fluorescence tool to measure metals. So we're doing a lot of work over in Pueblo at the Colorado smelter. And one of the things that came up for us over the course of doing that, mostly we're looking at outdoor yard cleanups. One of the things that came up was we started looking at dust levels in some of the homes. And the emergency response folks actually had to go in and do some cleanups because we had over % levels of lead in dust in some of the carpet pads and carpets in some of these homes. So we're talking, one of the largest numbers I saw was 17,000 ppm lead in a carpet pad where children might be crawling around on. And so we wanted to, one of the questions that came up post those cleanups, those in-home cleanups, was the questions about how much dust and how much metal loading is in the HVAC systems, in the heating, ventilation, and cooling systems of these homes. Most of these homes are literally built in the late 1800s, early 1900s. So the question came up, okay, we've spent all this time and effort, we've cleaned up inside the home. What is the chance for the living space to be recontaminated by dust that's in the HVAC systems? We did a small study of 7 homes. Suffice to say, most of the stuff was non-detect. We did find lead in a few of the HVAC systems that were at levels that would have exceeded the HUD numbers. And as you can see from the pictures at the bottom, what we did was we basically turned off the system, we monster vacuumed all of the HVAC systems, cleaned all of that out, then restarted the systems. And we were looking for lead to show up, basically, or lead and arsenic to show up in those little taped one-by-one tiles, and then we did wipe samples on those tiles. Most of it was close to non-detect. So at least now we have some data that we can point to homeowners to say that we don't think that there are large quantities of lead and arsenic in the dust in the HVAC systems. And there's even less chance of that actually being transported out of those systems back into the living space. But it's a really small data set, like I said, 7 homes. So we want to follow up on some of that. Now to Bonita Peak. I just got an email yesterday that it appears that we are looking to do some activity-based sampling. So we're looking at metals inhalation exposures. And typically the way we do it, which I hope we get to do, looking forward to it, but basically you get to strap on all of your PPE, put on a little a filter or a sensor on yourself, and then we get to drive around on ATVs on roads and capture that material to get estimates of inhalation exposures for metals at these types of sites. The email I got recently was some data there may be some issues with manganese and others. So we are looking to do activity-based sampling on some of the roads right up here in Bonita Peak. And what we'd like to do is compare that to, don't know where the pointer is, but this little unit on the bottom. The fluidized bed extraction system was actually developed right here in Region 8, Dr. David Berry and others. And it was originally developed for asbestos and mineral fibers. Basically what you do is you take a soil sample, you put it in that little unit, and it's going to blow a bunch of air through the bottom. The smaller, finer particles and mineral fibers will rise to the top, be captured on a cassette filter, and then we can look at inhalation exposures. Like I said, it's typically been done with asbestos and mineral fibers. We're looking to do that same thing here, looking at metals. So we're trying to disturb those metals to see if we can get those captured on the cassette and ideally compare that to what is typically a much more expensive and time-consuming endeavor of putting people in suits and driving around on ATVs. So the idea would be to take the fluidized bed extraction system. We're going to collect incremental soil samples along those same places where we're doing the activity-based sampling, and then see if we can get a good correlation, because this is a much faster and cheaper option for us. So that would give us opportunities to increase our data density and check out more of these inhalation exposures than we typically can with an activity-based sampling. Just some of the stuff we're doing now. Developing QAPs, we had to tweak the method and the filter systems to go after metals as opposed to some of the mineral fibers that typically we do. And ultimately, we're going to pull all this together and share it both in publications and also through some of our webinar series. Here's another one that I just heard about in the last few days. I was successful in winning what's called the Office of Research runs a program called the State and Federal Innovation Projects. This is a picture of some of the projects from 2017. In fact, our 2017 winner was actually a project done up in Montana where we're looking at harmful or algal blooms, and essentially they're using a smartphone application to capture pictures of the algal blooms and then transferring that information to the state of Montana, where they can look at opportunities to figure out where there are algal blooms happening. Are they actually, harmful algal blooms, and look towards mitigation strategies. And that's on the Smith River in Montana. Fast forward to 2018, I've been trying to do this now out here at Bonita Peak for a few years, and I've been unsuccessful in some of my proposals. I just found out this year we We were successful in winning the 2018 innovation project, and we're basically looking to do temperature and conductivity profiling in some of the streams out here. And in particular, we want to use that second bullet tool right there. We're really excited about using something that was developed originally by USGS, this fiber optic distributed temperature sensor. So basically, it's a long fiber optic cable. You can have it many kilometers. You're going to fix it to the stream bed, and you could shoot a laser all down that along that fiber optic cable and get really high resolution, about 1 meter spatial resolution, and really good thermal resolution, about 0.01 degrees Celsius. And that will give us a lot of information about interaction between surface water and groundwater. A good one that Rob Runkle showed yesterday was that seep, and so we'd like to do, some parts of Cement Creek and others. And actually, because this was just selected, I'm sort of in a rush mode now because we're in good base flow conditions. We want to try to get some of that work done here in the next few weeks or months. We're also going to be doing these little cheap sensors, and my understanding is there's some of them already out here in the watershed, but these little, there's different sensors we can use, these little pendant sensors. This is an example from Onset, but Andrew Todd, who came to us from USGS and is now a member of our Bonita Peak team here as well, has been helping me out with some of the options we have. This was actually a sensor that was a temperature and light sensor. They actually, in this particular paper, they actually hijacked the optical sensor and created it and turned the electronics of that into a conductivity sensor. So we're looking to use this type of approach to do conductivity here, and these are about $50 a piece. So I'm hoping to get my hands on a whole bunch of these sensors, and we're going to string them across the streams along certain stream banks, so on and so forth. You can leave them in place for weeks or months. They're going to log the whole time, and we'll have a really rich, high-density data set for things like conductivity, temperature, and we may even be looking at some pH. Just to give you some perspective on in the red here, this is the specific conductivity that they mapped from hijacking that optical sensor and basically turning it into a conductivity probe. And it really matches nicely the more commonly used type of information from their conductivity probe. You can see you can pick up rain events and cycling, diel cycling, and things like that. So we're excited to get this really rich, deep data set. Here we're showing temperature in red, temperature in blue, and then the temperature from the sensor itself. And you can pick up things like freezing events. When the conductivity probe actually goes dry, we'll be able to pick up things like stream intermittency and all sorts of things. So we're really excited about putting a whole bunch of these things in the watershed around here over the next year and really getting a nice, rich data set to work with. How am I doing on time? 5 minutes? Good. So the last couple of slides here, just options for future opportunities. There are some other things that are on the horizon that we're chasing as well, and I think some of these things, the Bonita Peak Mining District would be ideal for us to do some of this research. In terms of water, I think we've seen all week what our challenges are. And still the Holy Grail has not emerged for us in terms of water treatment. We've had a lot of talk about what lime can do versus some of the other technologies, but we're still challenged by the types of flows we have here. We're talking, instead of tens of gallons per minute, hundreds or even thousands of gallons per minute that we need to be treating, concentrations of those, the types of ARARs, or the types of levels that we typically have to get to down to for some of our decision documents. All those things sort of culminate to be really challenging in the water environment, but there's been lots of promising advances. We've seen active and passive treatments and a whole bunch of promising technologies. For us, it's the issue of being able to scale those up to the types of flows that we need to be treating at a lot of these mine sites. And we do have some support from Superfund and also the Office of Research and Development, the Engineering and Tech Support Center out of Cincinnati. They've been given a little bit of money by Superfund, and I hope to be tapping into that to try to do what we're calling technology evaluations. People over the last few days have mentioned site and ETV. Before coming to EPA, I was in consulting and lab work. I remember doing many a great project under the site and ETV programs. Unfortunately, despite our pitch over the last few years to ORD, those programs do not seem to be coming back. So we are limited with what we can do under a, quote, technology evaluation, but there were some examples shown yesterday about how we can do that under Superfund, how we can do pilot testing, and some of the other things under Superfund. So I hope to work with our other federal partners and actually do some of this also on some of the EPA property, or EPA, where we're at here in the watershed. And for me, it's sort of that last bullet, the holy grail. Can we be more targeted? Can we be more surgical with how we're doing these remedies? Keeping clean water clean, dirty water dirty, and treating the dirty water. And ultimately, can we be preventative? There are technologies out there where we can try to actually slow or stop the pyrite oxidation from happening. It's sort of the bane of our existence with this acid mine drainage. And so I'm very focused on technologies that can sort of be preventative, so we don't have to be treating thousands of gallons a minute, particularly with lime that everybody's not so fond of. And then on the soil side, the solid matrix side, there's some work going on right now. Removal programs looking at mixing some of the sludge from the Gladstone plant with Kitty Mac tailings and lime as a stabilization technique. There are lots of piles of materials around here that could benefit from some of those stabilization techniques, so that's going on. I wish I had some data to share with you. I don't. And here's kind of the latest one that got dropped on me very recently, which is the idea of converting arsenic and lead minerals into this Aracite material. We actually stumbled across this. One of our risk assessors here in Region 8, Dr. Charles Partridge, was in the Clear Creek watershed, and we were doing bioavailability, in vitro bioavailability tests, and we were getting back results below 5% bioavailability from a series of samples in the watershed, which is not very typical. Lead is typically on the order of maybe 60 to 90% bioavailable. You'll find arsenic a little bit lower, perhaps in the 30 to 50 range. And we actually did the test and couldn't believe the results, went back and did the bioavailability test again, and lo and behold, there are minerals out there with extremely low bioavailability. And one of them is this top one here, this Plumbow Aracite. That's what I want to talk to you about today. We're working with Dr. Kirk Shekel out of ORD's National Risk Management Research Lab. Really a great guy to work with, particularly on metals issues. He gets time at the facility you see there. That's a particle accelerator, the cyclotron facility. He's able to get, quote, beam time, so we can send him samples and he can actually speciate, like in this case, where the lead is at. So is the lead in a sulfate form or an oxide form, or in this case, the signature at the top, the black line, that's the Plumbow Aracite mineralogy, which seems to have such great stability and low bioavailability. So basically the lead in this case, that's the mineral right there. The lead would substitute for the iron. Arsenic's going to come in through that sulfide group. And really, the point is, particularly on the solubility, really low solubility there at the bottom, on the order of the types of minerals like galena and chloropyromorphite with really low solubility. So if we can convert these minerals into that, we're doing well. The challenge for us, unfortunately, to do this, and we stumbled upon some work that was done in early 2000s, was actually metal plating. We're basically taking that same process that they were using in metal plating, and we're reversing it to try to lock the arsenic and lead back up in this Aracite mineral. Unfortunately, we have to heat the soil. So that's going to be a challenge, 80 to 100 degrees C for about 30 minutes. So basically, we're going to sterilize the soil, and it's also going to release some sulfate, which is going to reduce pH. So we would have to probably re-inoculate the soil with microbes and amend the soil to adjust the pH. But it's something that we're looking at sites in this area to try to do as well, maybe something in 2019 or 2020. And again, just some quick pictures at the top on the left. Those are the pre-treated bioavailability percentages. Lead typically on the order of maybe 70 to 90%, and then post-treatment, these are 0.1% bioavailability now for the lead compounds. Along the bottom, same thing to the right for arsenic. you're starting off with bioavailabilities around 20 or 30%, and you're ending up with post-treatment bioavailabilities about 0.5%. So if we can lock that stuff in that mineralogy, up in that mineral, we think it has high stability and a lot of potential opportunities for remediation. So we're looking to try to do some work with that with Kirk Shekel right here in the watershed. And with that, I will take questions.
Wow, that was a lot of stuff. That's really cool. I love the way you're actually bringing up that treating the soils is as important, dealing with soils is as important as water, that there's multiple avenues, there's multiple pieces to this problem. Understanding it, being able to deal with it, being able to break it down.
Yeah, and just so happens we've been doing a little more work on the soil side, but I'm pretty excited about the new work with the distributed temperature sensors and some of the characterization that we can do in the watershed. So, any questions? All right, well, I hope maybe next time around I can actually share data on some of those.
Yeah, congratulations on your award.
That's a good question. I'm not a microbiologist, but I did look at the temperatures and thought to myself, okay, if we did this in a yard, for instance, and you heat the soil up, first of all, how are we going to do that? There's some challenges. We've been talking about putting bisqueen over stuff and just letting the sun heat it up. They have something you can tow behind with a tractor and sort of injecting steam to try to get those temperatures up. But in terms of the inoculation, I just, knowing that those temperatures are like that, we would assume that basically you're going to sterilize the soil. So yeah, we'd have to talk to our folks about how we're going to adjust the pH post-treatment and how we're going to reestablish, Marty's pointing to his stuff in the back, how we're going to reestablish those microbial populations. So we haven't got there. I just noted those as some challenges that basically when you're going to heat the soil up like that, the sulfate that's going to be released is going to be a challenge for us to get the pH back to where it should be, and also reestablishing those microbial communities. So I would lean towards my my microbiologist friends to help me out there.
Perfect.
Will you have a chance to comment on it? Like I said, we're looking for pilots right now, so I just noted that as a challenge. We want to see if we can actually do this on sort of a pilot or field scale, and then those other post-treatment challenges will definitely be something that we're looking at. Whether or not we're going to put it out for comment, I'm not sure that process, but if this moves forward, and right now we're just looking at pilot sites, maybe when I can share some data next time around, I'd be happy to get comments from folks. And particularly if we do it in this watershed, I will be back probably during one of the local events to try to share some of those results with you. And at that time might be a good time to have the discussion about how we deal with reestablishing the soil matrix on the back end.
Perfect. Thank you. Thank you. And Bill, you bring up a really good point, actually, is that there is a very definitive process for how final actions go through a public review and comment process. But what is the process for engagement on more of a pilot and a testing type thing? That's something we haven't touched on at all, and I'm not sure exactly how it works within the EPA and or other agencies. But it brings up a great point that exchange is an important piece, and there's some good knowledge and opportunities to share that. So thank you.